Hey guys, so I'm going to go through Appendix C. There are 3 goals in Appendix C that I want you to be able to do. They are to read and interpret a bar chart, to read and interpret a line graph, and to read and interpret a pie chart. There are some old tools that we had that are going to come back up again, and when we get to those, I'll be sure to mention them. All right, so to jump right in, the first thing we're going to take a look at is over here on the left-hand side. This is a bar chart. This is what's known as a dual bar chart or a comparable bar chart. You will see that what we're comparing are the number of marriages in the U.S. between whites and African Americans. The white husband and the African American wife is listed in red. The African American husband with a white wife is listed in yellow. I'm going to use the word Caucasian. I don't know why. I just prefer it. One of those things. All right. Along the horizontal axis, we have the year by decade, starting with 1970, 1980, 1990, 2000, and 2010. And then up the vertical axis here, it is the number of marriages that are being counted in the thousands. So this 50 actually represents 50,000. The 100 actually represents 100,000. Just because these numbers are small to save space and for conciseness, but the word thousands here indicates that we're going to multiply all these by thousands. This figure is taken from James M. Hensley, Sociology 11th edition. It is a Pearson text from 2012. So as you may have noticed, some of the verbiage may be a bit outdated. Some of the wordage may be a bit outdated. All right, so I've got 6 questions based on this particular graph. And yeah, we're going to take a look here. I'm going to backspace that. Okay. So in 1970, approximately how many interracial marriages were there? So from this chart, I'm going to come over here. Where's my draw? Where am I? Where am I? Where am I? Where am I? Oh, I'm way over there. Come on over. Oh, this is flipped. Pardon me a moment while I get things straight. Okay. Yeah, there we go. So I'm going to use my draw. I'm going to pick a color. There we go. So we're going to take black. So we're going to take a look here at 1970. And in 1970, approximately how many interracial marriages were there? So we have 24,000 with a Caucasian husband and African American wife. And we have 43 with an African American husband and a Caucasian wife. So, right, these days there's a lot more things that we count for interracial marriages. Clearly, this did not include all possible marriages, but it did include some. So we're going to work with this chart as it is. This would be 67. 24 plus 43 is 67. Or 67,000 would be the correct answer because we would want to multiply this by 1,000. Clearly, they were not just 67 marriages between interracial couples in 1970. In 1990, we would do the same thing. We would simply look at 1990 and we would take the 61, and to that we would add the 150 to get us 211. And again, we would want to multiply that by 1,000. So that's going to give us 211,000. All right. Question number 3 asks us to take the percent increase. Percent increase is a tool we used at the very beginning of the term. Percent increase is found by taking the difference in the 2 data sets and dividing it by the original number. Now, the differences would be the difference in interracial marriages, the difference numerically in interracial marriage from 1970 to 1990. So we're going to grab the calculator and we're simply going to pop that up. There we go. We're going to take 211,000, 211. And we're going to subtract from that the 67,000. So we're going to get a difference. There we go. Of 144,000. Oops. Which we need to divide by the original amount. Now, we have 2 amounts. We have the amount from 1970 and the amount from 1990, right? Yeah. We want the original. The original would be the first one in time. So that would be 1970, and that amount was 67K. So we want to take 144K, and we want to divide that by 67. So I'm just going to hit divide by, and then 67. And that's going to give me a 2.149, which they asked for the percent. So I'm going to multiply this by 100 to get 214.9%. Okay, or move the decimal point 2 places. Either one will work. Problem number 4 is a similar, the percent increase from 1990 to 2010. So for 2010, we're looking at 390 plus 168. We have 390 marriages with an African-American husband and a Caucasian wife, and 168,000 marriages with a Caucasian husband and an African-American wife. And this gives us, oh, did I just do, no, that's right, 558K. So I need to take 558,000. Oh, where I want this one. I want my calculator. There we go. So now I want 558. Well, let's just check my math, because let's do 390 plus 168. That's 558,000. That's what I had. We're going to times that by 1,000 to get 558,000. That's the number in 2010, which I need to subtract the 211 from 1990, because it was 1990, which I already had, 2010. That gives me 347,000, which I want to divide by the original or first one of 211. Okay, so now I'm going to go back to my calculator. I'm going to divide by 211,000. So I get 1.6445. So I'm going to change this to a percent. I'm going to multiply it by 100 and put the percent 164.45. I'm just going to go with 164.5% because I went with tenths on the other one. So 164.5% increase in interracial marriages from 1990 to 2010. All right, that works. Okay, scrolling up a little bit. In what years were the number of interracial marriages under 200,000? Well, if they're going to be under 200,000, they have to add to less than 200. Because it's 200,000, if I take, and remember, all of these numbers are in the thousands. So 200,000 and divide it by 1,000 to account for the place value. Everything needs to be less than 200. Well, that's going to happen in 1970 and in 1980. Right? What number or what years were the number of interracial marriages over 300,000? That's going to be 2000 and 2010. Because 300,000 will convert to just being less than 300 when we add them together. If we take 95 plus 268, I don't need to know the number. I can see that's going to be over 300. And 168 plus 390 will also be over 300. So I'll be okay there as well. All right. Okay, I'm going to move my face to the other side. There we go. And then I'm going to go ahead and do this one with the line graphs. Now, as we take a look at the line graphs, this is a women's average age of first marriage. They've tracked this data from 1890 all the way up to 2010. You can see that the horizontal axis shows the years, skipping by tens. Every 10 years is known as a decade. So this is 1990, 1900, or I'm sorry, 1890, 1900, 1910, 1920, 1930. So even though these are missing, we can assume because they appear to be in the middle that it is between 1920 and 1940, which is 1930. All right. So these are the years that they've taken this data or that we're plotting this data. Along the vertical axis, we see the ages. Notice that they should start at 0, but they haven't. So what's happened here, there we go. What's happened here is they've put in this tiny little, I want to draw, there goes my face again. they've put in this tiny little, like, sort of lightning bolt, right? So if we were to blow that up, that goes like this. Looks like a little heartbeat. And basically what this sort of zigzaggy thing there means is that even though this is supposed to start at 0, they've jumped. They've jumped and started directly at 20. So this is 0 to 20, and they've skipped 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. They're just skipping them all. And then they're going to count 20, 21, 22, 23. This is a rather normal tactic. It's not recommended, but lots of times people do it just to make the graphs more succinct when we draw them. Doesn't always make them easier to read. It does make it easier to misinterpret. So just so you understand where that is coming from. All right, so we're going to estimate the woman's average age of first marriage in 1950. So we're going to find 1950, which is right here. I'm going to grab my highlighter. And we're going to follow 1950 up. Look at where 1950 crosses our line. Do you see that? Do you see how it's pretty close to 20? It's not exactly 20. So I would say the woman's age of first marriage here is about 20. This would be a young 20. Would not yet be 21, wouldn't be 20 and a half. They would have probably just turned 20 a couple of months ago. All right. In what year or years was the average age of first marriage 22? So I'm going to come back here to my draw. I'm going to grab this. I'm going to find the age of 22, and I'm going to draw a cross. I'm just going to highlight it. Now, do you see how with that highlighter, I can cross not 1, not 2, but 3 points? Now I'm going to follow those back down to see where those occurred. And those appear to have occurred. Where am I? There we go. Those appear to have occurred in 1890, in 1900, and again in 1980. So what was the average age in what years? Well, that would be the 1890s, 1900, and 1990. Right? During what decade do you see the greatest drop? So decade is every 10 years, and lucky for us, we're counting by 10 years here. So that part is good. I'm going to go back and grab my eraser. There we go. All right, so during what decade do you see the greatest drop? Now, drop means it's going to fall down. So I'm looking for when my line goes down as I read it from left to right. So from 1890 to 1900, it's going down, down, down. This is up, up, down, up. Oh, it kind of stays the same there. And then it climbs. All right. So which is the greatest drop? In other words, when does it fall the fastest? And that seems to be from 1940, to 1950. That decade, the decade of the 40s, 1940 to 1950. Now, what was going on at that time that might have caused the age of marriage to drop? Well, 1940s was World War I. Why would people want to get married so badly in World War I? Societal-wise, I believe that a lot of times, and you can correct me if I'm wrong, I'm not the history, I'm the math, but I believe a lot of the young people were getting married before the boys went off to war. At least that's sort of the historical memory that sits in my head, that like young girls wanted to get married and young boys wanted something to come back to. So that could be why there was a little bit of a drop. And it seems like it's a big drop, but it's really just a year, right? Because 1940 was just over 21 and 1950 is just over 20. So yeah, it's a drop, but it's really not that huge. During which decade do you see the greatest increase? Now, increases is when they're going up. So we want to look at when they're going up. That's the 20s and the 30s, the 60s, the 70s, the 80s. Oh, look at the 80s. The 80s seems to be the steepest climb. So the 1980s seems to be the steepest climb, which makes sense to me. That's when a lot of women went back to work because of the economic hardships. So they went back to work. They sort of held off on marriage. A lot of things happened in the 80s. All right. Problem 11. Determine the rate of change in age from 1980 to 2010. Rate of change, if you recall, is the slope. So we need the slope. Slope is the rate of change. We have done this before as well. So we're hearkening back to algebra unit. If you remember, slope is your m, which is y2 minus y1 over x2 minus x1. And the key here is to take a look at 1980. Let's grab my highlighter. So for 1980, if I follow that up, look at that, I get 22. And if I look at 2010 and follow that up, I get 26. So what we're going to do here is I'm going to go a little thinner. There we go. Is I'm going to think of these like points. I'm going to do 1980. Oh, I like that better. And that was 22. And then I'm going to think of 2010 as 26. Then what I have is my x1, y1. So now I've got my x1, y1, and my x2, y2. All right. So this would be 26 minus 22 over 2010 minus 1980, or 4 over 30. This reduces to 2 over 15. What does it mean? It means that if you look at what the y's are our ages in years. So I'm going to, right? So our y's are our ages in years, and our x's are the years, like the decades. Okay? So we are increasing because it's positive. The rate of change is a 4-year increase. 4-year increase every 30 years of time. Or in reduced form, 2 years increased every 15 years of time. So every 15 years, the average age of women is 2 years more. Or in order for a woman to be 2 years older before they get married, 15 years from the last stated average has to change. No, I said that wrong. The average age increases every 15 years of time that went past. Now, that doesn't necessarily mean that by 2025, the average age will be 28. I think we may already be over that. I think I read someplace that the average age by 2020 was already 28, average age of first marriage. But whatever, neither here nor there. I don't have the data to support that. It's just anecdotal. All right? Okay, so we brought back the slope. Oh, Lord. So what have we learned so far? Well, I can bring back percent increases, rates of change. I can bring back slopes. All of this can be gotten. So, yeah, there's big picture here. All right, let's try this last one. I need to get my drawback. I need to get black back. All right, determine the percent change in age. So the percent change, again, is the difference over the original number. All right, so from 1980 to 2010. Oh, I've already got those ages. Thank you, Amy. So 26 minus 22, the difference there is 4. But I don't want the slope this time. I want to compare that to the original age, which was 22. And then I want to grab my calculator, and I want to do 4 divided by 22. And that gives me 18.18, 0.18, repeating 18, 18, right? So it's just 18 over and over again. So to convert that to a percent, because they want the percent change, I'm going to multiply by 100. So that's going to give me 18.2, because that 8 will round that. So 18.2%. All right. Okay, next one. I'm going to pull my face over to the other side. Oops, will it not let me? Let's see. There we go. Aha. And then I'm going to scroll back down for the pie charts. All right. Now, for the pie charts, we have a lovely pie chart circle graph. It's a breakdown of a monthly budget, something we should all have and do, even if we don't. And you can see the breakdown here is for clothing, healthcare, entertainment, transportation, food, childcare, and housing. Now, each one of these different colors represent a sector or a piece of this pie. This sector is dedicated to one topic. For example, the green sector is 30% and it is dedicated to housing. The orange sector is childcare and or education and it is 18%. The red sector is 16% dedicated to food. Transportation sector is 14%. Entertainment is yellow. Healthcare is purple. Clothing, it looks like they did red again, but I think that was supposed to be a different color. I think the printer just kind of turned out a little weird. But okay, each piece of this pie, each dedicated portion is known as a sector. Okay. Some of these questions can be really, hopefully, straightforward. What percent of the monthly budget, there we go. Yeah, I could use a glitter, but I won't. What percent of the monthly budget goes to healthcare and to education? So healthcare is 8%. Education is 18%. So together, this makes up 26% of the budget. All right. Which sector is the largest? That would be housing. Because that's 30%. We can tell based on the amount of the circle that it takes up, and we can tell based on the number, it is 30%, and that is greater than any other. How many degrees of the circle does the sector have? Ooh, okay. So because it's 30% of the budget, it must also take up 30% of the circle. Do you remember how many degrees are in a circle? We talked about this, which is 0.3 for 30% times the 360 degrees in a circle. So now I'm going to grab my calculator and do 0.3 times 360, and that tells me 108. So if somebody grabbed a protractor, like we did with the geometry unit, and they measured this sector, how many degrees that angle there would be, they should get 108. Where'd my, right? Okay. I feel like something happened. If you're still with me, guys, hold on. Hi, there I am. I'm still sharing. I think I'm still on here. I don't know what's going on. All right. Let's take a look at number 15. If a home has a monthly budget of $1,800, how much would be spent on entertainment? Entertainment is 8%. And that's going to be 8% of the monthly budget. So it's 8% of that 1,800. So now I'm going to take 0.08, converting the percent to a decimal. And I'm going to multiply that by 1,800. I'm going to grab the calculator and do 1,800 times 0.08 to get a monthly budget of $144 for entertainment. That doesn't sound too bad. I don't think I spend that on entertainment, but maybe if we count some of I'm not a gamer, so that part never happens, but maybe if we count some things like some of my Hulu or my Netflix, that would work. Okay, what about number 16? Here's where we use some of the percents that we did before. If a home spends $690 of their budget on housing, what should their monthly budget be? So I don't know the monthly budget. The 1800 from 15 is gone. We're not using that. We're starting with a clean slate. They spend $690 on their housing. So $690 is housing. And we know that housing is 30%. So the $690 is 30% of the budget. But we don't know the budget. So 690 is 30% of something. So we get 690 equals 0.30 of some unknown. So now I've got to take that 690 and divide it by 0.3. I'm going to divide it by 0.30, and I get 2,300. All right, pull this over here. So 2,300 should be the budget. There we go. Oh, not 230. $2,300. There we go. All right. Okay, if a home has a budget of $2,400, sorry, how much should be spent on the essentials, which is food, clothing, and housing? If I add them, food, we have 16%. Clothing, we had 6%. And housing, we've got 30%. That's going to be 52 if I add it all up. So what is 52% of that 2,400? So now when I grab my calculator, I'm going to take 0.52, because 52% as a decimal is 0.52 times the 2,400. There we go. Get 1,248. So $1,248. Right? Okay, if a home has a budget of $400,000, how much more is spent on transportation than on clothing? So transportation was 14%. Clothing is 6%. How much more means I'm going to subtract it, so 8%. So we need 8% more of 4,000, or 0.08 times that 4,000. Ooh, I think that's going to be 32. 0.08 times 4,000. 320. Okay. So there's about $320 more spent on transportation than the person spends on clothes. They're probably spending an awful lot on transportation and are not buying many clothes because of it. All right, so that's Appendix C. I've gone through all 18 of those questions. It's been a little bit more than half an hour. I'll edit this a little bit and try and mark out. If I upload to YouTube, I'll try and put in the chapter contents for you. All right? Thanks, guys. Let me know if you have any questions. Bye-bye.